Okay, thank you very much. So let's start with a question from Slack. Sudong Sun from UIUC. I might miss some details, but how should we decide S0? Is it a configuration parameter that you need to tune? Is there a formula or some insight in tuning this parameter?
Yeah, a larger S0 can enlarge chunk sizes, thereby increasing average disk read bandwidth, but at the cost of increased disk network traffic due to the usage of RS code. It also adds overhead to pipelining, since the first chunk cannot be pipelined and increase the average degraded read time. So we should tune the S0 before we put objects into the storage system based on the trace we use.
Okay, thank you. So I have a follow-up question actually. So you mentioned that we need to tune the S0, right? So could you share some experience on how you tune the S0 to get an optimal value which achieve such good performance?
We have tuned S0. For example, we have tuned S0 to 1 megabyte, 4 megabyte, and 16 megabyte in the paper, and we have shown that the results are similar. So they have similar performance. So when we change S0, the performance won't vary much.
No, thank you.
Thank you.
Other questions, Slack or? So let me ask you one question. I really enjoyed reading your paper, but one thing that got me wondering is whether you'd be able to serve update workloads as well. As right now you only serve reads, right? And you have a pretty elaborate algorithm. So if you'd have to modify the data, I suppose that would lead to all sorts of additional operations, and writes could be penalized. Do you have any thoughts on that?
Well, we can serve. For example, we can use geometry partitioning as a basic layer of the storage system, so they can store some logs and tables. If we want to update some objects, we can store them into the logs, and we can pro.
So this is just like we can use logs to. You're right? So it is not easy to directly update the data in place. So we can just use logs, and later by using background applying procedure to apply the data to maybe underlying storage.
Okay, Thank you. So we have another question in Slack from Niels Tseng from Boston College. A slightly off-top question: how often and how much data do you need to repair in a real cluster?
Well, we may need to repair about from hourly to daily, depending on your cluster size. If we have a cluster with thousands of disks, we may repair daily. If we have tens of thousands of disks, we may repair hourly. So it depends on your cluster size.
So there's some reference in the paper and some data provided by the industry. So that maybe answer your question about the experience of how often we may need to repair.
Yeah, I think it's more wondering in practice in a typical cluster, how long it would take to repair. Okay. So he's happy with your answer. I don't know if any other questions. Okay, let me go with another one. So would it be possible to reconfigure? Let's say you choose some S0, and for some reason realize that it's no longer an optimal value. Would you be able to reconfigure, and what would be the implications of reconfiguring the system for different parameters?
We have not investigated how the change the configuration for the different parameters of S0 and including Q, right? So in our experience, because as mentioned before, the size of S0 does not influence too much. For example, for a hard drive. So we expect not very often to change the S0. And if it does need to change the S0, I do think we needed to set up a new cluster to maybe when you buy a new cluster and use new devices, and you may need to tune the parameter again.
Okay, so you're saying that this is meant to use fixed parameters once you install the system, and then you don't want to change them on the fly. Okay.
Mm-hmm.
Okay, so unless we have any other questions, I'd like to thank you very much, and we're gonna move on to the next.
Okay, thank you for that talk. As a reminder to the audience, you can either raise your hand if you want to ask a question live, or ask a question in the chat thread and we'll go for you. Looks like, you've got another question here, so why don't we have you ask that?
Yeah, sure, yeah. Hello, Yingdi, did I pronounce your name correctly? Yingdi, yeah. Thanks for the great work. I'm Hino from NUS. So my question is, it's interesting that you divide the chunks depending on the geometric sequence. And my question is it the value of the sequence of chunks, is it tunable or is it fixed? From your presentation, I saw is it S0? The first chunk size is the S0, and it is decided depending on the geometric sequence. I wonder if those variables are tunable or is it fixed, or how to decide those values? Yeah.
Okay, thanks for your question.
Yeah.
We have two parameters, S0 and the Q. They can be tuned before we put the objects into the system by sampling the trace. And after we decide S0 and the Q, we put objects into the system, these two parameters are fixed.
I see. Okay, yeah, thank you.
Thanks. I have a question for you, which is often, storage systems that are, have erasure code or otherwise will have a lot of caching in front of them to handle the read load. And so my question was, does the caching and what type of caching is available affect how you select the parameters in your geometric partitioning?
We think that our geometric partitioning should be used in the background and the storage system to store the data. And we have not considered using the cache system. Of course, cache system should consume maybe large amount of traffic. But when we do need to access the background storage system, it is the regeneration code that can be used.
A variant of this is that sometimes there are types. Sometimes we lose data, we lose a replica for an unplanned reason. The machine just fails. But other times it's a planned reason. There's a kernel upgrade, there's maintenance. We know that it's going to happen. And this is kind of what I was thinking. Is it possible to co-design this so that you could handle that in the caching system and therefore reduce the need for doing degraded reads in at least in those planned situations? You still have to do it in the unplanned situations. Does that make sense?
I just think that this our usage scenario should be for some unplanned scenario. For the planned scenario, for example, we can just resort to the recovery, and there will be more often to recovery. For example, you want to upgrade your storage system, and you will regenerate or recover all the data you need, right? And for the repair, for degraded read, that will be the situations for accidentally lose some objects. And that should happen quite often in nowadays scale of storage systems.
Thanks. It looks like Andrew wants to ask a question.
Yeah. So I was just curious how often these types of failures are happening where you're losing blocks in these data center scenarios, or disks, I guess, sorry, that you're losing in data center scenarios.
Okay, thanks for your question. It depends on your cluster size. If we have a cluster of about thousands of disks, these failures may happen daily. If we have a larger cluster, these failures may happen hourly.
Okay, so we have some references in our paper from the industry, and they will maybe tell us about the failure rates of everyday disks. For example, I don't think that Google has revealed their statistics about the disk failures.
I see. I was just kind of curious. I mean, you're seeing huge wins, but it's hard to evaluate if it's sort of like a daily problem, how to evaluate that, right, in terms of what's happening. So hourly sounds maybe more bad, but like, you know, it's just sort of hard for me to contextualize that. And that's kind of where I'm coming from. But thanks. I'll check out the references you mentioned. So.
Okay, you're right. So we are trying our best to maybe put some normal operations on top of our system to test whether it may influence the normal access performance.
Great, thanks.
Okay.
Okay, thank you for answering those questions. And I think we'll move on to our final paper of the day, or sorry, not the day. If it's late for me here, but not for most people in this session. We'll move on to the final paper of the session,